Today we are covering section 5-7, the Pythagorean theorem. Make sure you take notes and complete the check it out problems.
We have two learning targets today. The first one is I can use the Pythagorean theorem and its converse to solve problems. And the second one, I can use the Pythagorean inequalities to classify triangles.
All right, so the Pythagorean theorem, you've already used it in the past. It's probably the most well-known mathematical theorem out there. And what does it say? It says if you have a right triangle, so you have to have a right triangle first, the sum of the square of the legs, so our legs are A and B, so the sum of the square, and you should square before you add, is equal to the square of the hypotenuse. And just remember, the hypotenuse is the side opposite the 90-degree angle.
So our first example, we want to find the value for x. The key thing is to remember simplest radical form will be your answer. No decimals. You might have the radical sign still. So we have the 2 and 6 are our legs. X is our hypotenuse. This is our A, B, and C. So 2 squared plus 6 squared equals x squared. So 4 plus 36 equals x squared. 40 equals x squared. Square root both sides. Square root of 40 equals x. But now 40 has a perfect square. It's a factor. Happens to be 4. Square root of 4 is 2. So we get 2 square root 10. And that's what our x will equal. Kind of squished it in there. So x equals 2 square root 10. Simplest radical form. For our next one, we have, this is our A, B, and C. So 4 squared plus, here make sure you group the x minus 2 and square that whole quantity equals x squared. So 4 squared is 16 plus, this x minus 2 we have to FOIL. So our first term we get x squared minus 2x. The negative 2 times x is negative 2x plus 4 equals x squared. Oh, thanks for the extra x in there. Ooh, that looks bad.
I'm sorry.
So now we can combine like terms, simplify on this side, so we're going to get 20 plus x squared minus 4x equals x squared. Subtract x squared from both sides, we get 20 minus 4x equals 0. Add 4x to both sides, 20 equals 4x. Divide both sides by 4, we're going to get x equals 5.
All right, so now we have two problems for you to do. Make sure your answers are in simplest radical form.
And here we have a story problem. Randy's building a rectangular picture frame. He wants the ratio of the length to width to be 3 to 1. That's going to be an important ratio there. The diagonal is 12 centimeters. And we want to find out how wide the frame should be. So let's draw a picture. So here is his rectangular frame. Rectangle means the 90-degree angles there. Diagonal is 12 centimeters. So this would be our A, B, and C. Instead of 2, let's go with a C. So now we have our length is 3, so this would be 3x. Our width is x. So our equation becomes 3x squared plus x squared. So I almost made a mistake there. Group them and then square it. Equals 12 squared. This is 9x squared plus x squared equals 144. So we get 10x squared equals 144. Divide by 10 on both sides, 14.4. This case, you want to round to the nearest tenth of a centimeter. So x is going to be about, so put 1.4 or 14.4 to calculator, square root it, and you're going to get x is about 3.8.
Very nice.
Thank you.
All right, so now you have one to check it out. And according to the recommended safety ratio of 4 to 1, how high will a 30-foot ladder reach when placed against a wall? So
Can't wait to hear the answer.
that's right. So you're going to use these, and remember, you're going to use them in the form, 4x and x for 4 to 1 when you solve your problem. Good luck.
So now we're going to look at Pythagorean triples. A Pythagorean triple is just a set of three non-zero whole numbers. So they have to be, can't be negative, they have to be whole numbers, and they can't be zero. Such that a squared plus b squared equals c squared. And that's going to be a Pythagorean triple. So we have 1, 2, 3, the first 4 sets of Pythagorean triples. You should start to recognize these. So if you were to square 3 squared plus 4 squared equals 5 squared, and same thing with these other ones. These are all right triangles and Pythagorean triples.
All right, so let's look at an example. Find the missing side length, tell if the side lengths form a Pythagorean triple. So we're going to use our Pythagorean theorem and find the missing side and see if they are all whole numbers. First one, so here's our right triangle. So this is A, B, C. So we're going to have 14 squared, oops, plus 48 squared equals, that's not a square, is it? It's a degree sign. Let's try that again. 14 squared plus 48 squared equals c squared. This is our c, our hypotenuse. This is going to end up, if we put that in our calculators, we're going to end up having this equal 2,500. Remember, square the 14, square the 48, and then add equals c squared. Square root it, and you're going to see that c is equal to 50. So we have side lengths of 14, 48, and 50, which are all whole numbers. So yes, this is a Pythagorean triple. Sample B, so notice our right angle is across from 12, so this is our c, or hypotenuse, and this will be our x. So we have x squared plus 4 squared, those are our two legs, equal 12 squared. X squared plus 16 equals 144. We're going to subtract 16. X squared is equal to 128. Square root it, and you can see this is not going to be a whole number. 8 and 8. So 8 square root of 2 is what equal to x, which is not a whole number. So the answer is no, it is not a Pythagorean triple.
Nice job. Now it's your turn. You have 4. So again, first of all, find the missing side lengths, and if all 3 sides are whole numbers, then it will be a Pythagorean triple. Looking at C right off the bat, C will not be a Pythagorean triple because we have 2.4. That's just silly.
Does some of your work for you there. All right, so now we're going to look at the converse of the Pythagorean theorem. So the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. So the converse of that says if a squared plus b squared equals c squared, then you know you have a right triangle. That can be very useful if you're out building something, want to make sure you've made a right angle. You can use Pythagorean theorem. If it works, then you know that you do have a right angle.
So now we have the Pythagorean inequalities theorem. So we know if a squared plus b squared equals c squared is a right triangle, but we can use that now where if c squared is greater than a squared plus b squared, then we have an obtuse triangle. Or if c squared is less than a squared plus b squared, we have an acute triangle. So think about the larger the angle, the longer c is going to be, the smaller the angle c is, and the shorter that length will be.
All right, so this may or may not help you understand it a little bit better. It's pretty much what Ms. Aiken just said. If Pythagorean theorem actually works so that c squared is equal to a squared plus b squared, then you're going to have a right triangle. That's the only time it will be a right triangle. If the side c is larger, and so c squared is actually greater than the square of the sum of the two sides, that means that your angle is going to be bigger since this side is actually bigger, and that's going to be obtuse angle. If c squared is less than the sum of the other two sides, that implies that c is a shorter side, meaning you're going to have a shorter or smaller angle, which means it would be acute.
Oh, one thing to also keep in mind is the little reminder down here, the inequality theorem, the sum of two sides lengths of a triangle is greater than the third side length. It's determined if we even have a triangle or not.
Correct.
Yes. Because we're going to need that for this one, classifying triangles. We're given 3 side lengths. So first of all, you have to say, will these side lengths even form a triangle? We can take the two shorter sides, 5 plus 7, and is that going to be greater than 10? Yep, 12 is greater than 10, so we have a triangle. So now we can use the inequality theorem, and we get 5 squared plus 7 squared. We're going to have 10 squared over here. We don't know which direction our inequality is going to go. So 25 plus 49, which will be 74. Thank you. And that's going to be 100. So we know 74 is less than 100, so our c squared is larger. This was our a squared, b squared, and c squared. It's larger, so this is going to be obtuse. And now look at b. Again, let's first of all determine, do we have a triangle? So take the two shortest sides, 5 plus 8. Is that greater than 17? 13 greater than 17? No, so we don't have a triangle. No triangle formed with those.
And you're done.
Yay!
All right, here are 3 problems for you to try. First, figure out if they make a triangle. If they do, then classify the triangle using the Pythagorean theorem and inequalities. So classify it as acute, obtuse, or right.
So, summary, we're just repeating the theorem. This is the Pythagorean theorem. A squared plus b squared equals c squared. You should be able to recognize at least those 4 sets of the common Pythagorean triples. It's going to help you make your work a little easier if you can recognize the different measurements there. And then our Pythagorean inequalities theorem. C squared is greater than some of the other squares of the other 2 legs, it's obtuse. If c squared is less than the sum of the squares of the other 2 legs, then it's acute. So good luck. Bring any questions to class. Thanks.